in order to simplify an algebraic expression, okay, we want to do a couple of things. The very first thing that we want to do is get the right size pen, okay? And now, the first thing that we want to take care of before anything else to simplify an expression, we want to change all subtraction to addition. Now, why would I do that? What would be the benefit of changing subtraction to addition? Alyssa? Yeah, why do we do it? Okay, we don't like to have minus minus right next to each other. Josh? It exposes the negatives. That way we have no hidden negatives. Good. A minus sign is basically the same thing as a negative sign, which can cause confusion. But if we change all that subtraction to addition, we'll have plus signs and negative signs, and that clears everything up for us. So the first thing we do is we change that subtraction to addition. That exposes the negatives. The next thing we do, after we can see all those negatives, we need to get rid of parentheses. Well, how do we get rid of parentheses when there's algebra involved? We distribute. Okay, like we just said, the reason that we distribute is distributing gets rid of those parentheses. It allows us to move the terms around, because the last thing that we need to do is combine our like terms. Okay, so first off, change all that subtraction to addition. And the reason we do that is to expose the negatives. Then we distribute so that we can eliminate parentheses. And then we combine like terms, because when we're simplifying, that's what we want. We want to have as few terms as possible. Now, there is one rule about combining like terms. What two things can you never, ever, ever add or subtract, Ryan? A constant term and a variable term. Good. We cannot add or subtract a constant term with a variable term. We can multiply or divide them all day, but we cannot add or subtract them. So let's look at number 2. Let's get started. The very first thing that we're going to do on number 2 is change that subtraction to addition. So I'll keep the 4 times the quantity, x, but instead of having x minus 1, we'll change that to x plus a negative 1. That way we can see that that 1 is negative. And when we work through the rest of the problem, we won't miss that. Okay, then I'll carry over the plus 4x plus 4. We didn't do anything with those two terms, so we're not going to adjust those two terms. We're going to leave them exactly as they are. Okay, then, after we change all that subtraction to addition, the next thing is to distribute. So, I have this 4 in front of the parentheses. I'm going to distribute that 4. What does it mean to distribute? What does it mean to distribute, JD? Very good. Multiply the number outside the parentheses, the coefficient, by each term inside the parentheses. So, I'll have 4 times x. I'll bring down that plus sign, and I'll have 4 times negative 1. Now, because we didn't do anything with 4x and the plus 4, we'll bring that stuff right down. Now, we can clean it up a little bit. Instead of 4 times x, we can just say 4x. And instead of 4 times negative 1, we can just say negative 4. And we still haven't done anything with plus 4x or plus 4, so we'll bring both of those down as well. Now, we want to look at combining like terms. Okay, we've changed all subtraction to addition. We've distributed. Time to combine some like terms. Well, what like terms do we have? Beth? 4x and 4x is one set of like terms. And Beth, what will I get if I add 4x and 4x? I'll get 8x. Very good. Okay? Then, what else can I put together? Is there anything else I can put together? B. Very good. I can combine negative 4 and 4. And if I add negative 4 plus 4, B, what do I get? 0. Okay, now, what happens when you add 0 to anything? It'll stay exactly the same. Okay, it's what's called the additive identity. So the only part that we need is that 8x. That is our simplified form of the original expression. Okay? I'll come back for questions in just a minute, so if you have questions, please hold on to them. Please don't forget them. I promise I want to answer them. Okay, now let's flip over to the back, and let's look at some equations. Now, to solve equations, to solve multi-step equations, there's a couple of things we want to keep in mind. First thing we always want to do is simplify. We want to turn a multi-step equation with a bunch of terms, parentheses, all that mess. We want to simplify it down to the smallest equation we possibly can. Okay, once we have it simplified, okay, then we solve the way we normally do. Reverse order of operations and inverse operations. We work backwards to isolate the variable. We ask ourselves, what are they doing to the variable? How do we work backwards to undo it? Okay, so let's skip a few, and let's go down to number 14. And let's look at number 14. First thing we want to do is we want to simplify. Okay, now, there's a trick that we do to all equations to try to keep things neat and organized. Who remembers what we do to those equations the very first thing? Willow? Before that, just to try to keep it organized. Very good. We want that vertical line down from the equal sign. Now, if you have trouble with the dotted line, solid line's fine. Solid line is fine. But you want that vertical line through the equal sign to help keep your work organized, help separate left side from right. Okay, now, Willow, we'll distribute. Okay, so I have this 8 in front of the quantity. I want to distribute it over that quantity. What will that look like? Very good. 8b plus 24. 8 times b is 8b. Bring down the plus sign. 8 times 3 is 24. Okay, now we keep our equal signs lined up. That's the whole point of that vertical line. And I haven't done anything to negative 32, so negative 32 falls right down to the next line. Well, that's simplified. I can't simplify that any more than it is. I have two terms, a variable term and a constant term. Sorry about that. Okay, now, we want to ask ourselves what we can do to get that b by itself. It's as simplified as it can be. I can't combine the constant term and the variable term. So let's ask what's happening to that variable and what do we do backwards to undo it. Okay, so what operations are being done to that b? In order. Okay, addition and what else? And which one of those is being done first? Good. It's being multiplied by 8, and then they're adding 24. So we're going to work backwards and undo each of those operations. So the last thing Stephen said was they are adding 24. So what's the first thing that we're going to do? Callie? Subtract 24 from both sides. We need to do the same thing on both sides. Again, that's where that vertical line helps us keep our equation balanced. Okay, now Callie, what's 24 minus 24? 0. So we have 8b plus 0. Callie, what about negative 32 minus 24? Negative 56. Very good. Now, the whole reason we bring that 0 down is so that we can keep track of things. If I add 0 to 8b, what's going to happen? It's going to stay the same. It's still going to be 8b. So, what can I do now to get that b by itself? Divide both sides by 8. Very good. Now, when we divide both sides by 8, what does that give us? What does that give us, Abby? I'll have b equals negative 7. And we could take that back to the original and sub it in. Okay, negative 7 plus 3 is negative 4. And 8 times negative 4 is negative 32. So the solution checks out. B equals negative 7 is the answer that we want.